Hello everyone, welcome to another lecture of the subject control system. In previous lecture, I think this is the number 14th. In previous lecture we started discussing about some elementary signals. There we discussed about impulse signal, what is an impulse signal. Now the next signal is step signal. Okay, uh, let me give you a small recapitulation of impulse signal. What is an impulse signal? An impulse signal also it is called as Dirac delta. uh, okay, what is a signal? Signal is some mathematical function which conveys some information. This can be the definition for our purpose. And impulse signal is denoted by delta t, where the amplitude is infinity at t equals to 0 and it's 0 elsewhere, t not equals to 0, provided the area under the curve infinity to minus infinity to infinity, delta t dt is equals to 1. Also it can be written as instead of minus infinity to infinity, it can be written as 0 minus to 0 plus. Why? Because impulse exists only at 0 value, t equals to 0 value. So if I so this is the representation, t equals to 0 value. So if I can integrate between 0 minus and 0 plus a small variation of 0, then also I can include the whole portion of the impulse function, and I can actually I will actually get the area under the curve. Okay, but one interesting fact is, if uh, I said how impulse function is generated, any symmetrical signal, let's say a rectangular signal, this is a rectangular signal, the width is minimized and the amplitude is maximized, thus the impulse signal is created. So if it is minus a by 2, it is a by 2 and it is 1 by a. So when a tends to 0, this function tends to delta t. Okay, now what happens is, now when a tends to 0, so minus a by 2 can be 0 minus when a tends to 0, and plus a by 2 can be 0 plus. Now instead of 0 minus to 0 plus, if I integrate from 0 minus to 0 itself, then what will be the value? Delta t dt. What will be the value? The value will be half here. Why? Because look, 0 minus to 0, 0 means this point, and 0 minus means when a tends to 0, 0 minus means this point. So only this portion will be covered. Okay, similarly if it is 0 to 0 plus, then also the thing will be half, because 0 plus means this point and 0 means this point. So only this portion area will be covered. So whenever it is 0 minus to 0 plus, then all the portion or all the area are covered, or if it is 0 to 0 plus or 0 minus to 0, then only half of the area is covered. This is basically impulse signal. And one more thing, if a is the coefficient of this delta t, what will it signifies? It signifies the area. It doesn't signify the amplitude. The amplitude is infinity, but the area is now a. Okay, so this is the thing, and this is the graphical representation where one doesn't represent the amplitude, if this one represents the area. For this signal it will be a. Okay, so this was impulse signal. I have discussed it. I hope this small recapitulation will help you. The next signal that we are going to study today is step signal. What is a step signal? Okay, a step signal, as the name suggests, there must be a step. That means the step signal can be written as, it is denoted by ut. Okay, it is denoted by ut. So how this function is defined? Ut is 1 for all t greater than 0 and 0 for t less than 0. Okay. So this is the representation of ut. So how it will look like graphically? This is the time axis and this is amplitude axis. So at t equals to 0, the value function is not defined, and for the moment t greater than 0, the value becomes 1. Okay, and it is constant. It is constantly 1. And before t equals to 0, that means for t less than 0, it is 0. Now there is an interesting actually a concept, because look, there is a discontinuity at t equals to 0. At t equals to 0, for step signal at t equals to 0, I have two different values. That means not two different values, but infinitely many different values. Like for t equals to 0 plus, just after t equals to 0, the value is 1, ut is 1. For t equals to 0 minus, ut is 0. T equals to 0 minus, ut is 0. So what is the value of t equals to 0? So at t equals to 0, this transition happens from 0 to 1, this transition. So at t equals to 0, there is no defined value of this step signal. There is no defined value. Okay. At t equals to 0, step signal is not defined. Now a scientist, a mathematician was there named Gibbs. According to Gibbs condition, whenever this kind of there are a lot more mathematics involved arriving to this Gibbs condition, but I will not go deep into that because that is out of our scope. Okay, so what the thing is, whenever this kind of discontinuity will happen in a graph, then we can approximate the value at the point of discontinuity. Where is the point of discontinuity? This t equals to 0 is the point of discontinuity. Now what Gibbs said, the condition is like at t equals to 0, the value will be value at just before t equals to 0 and after t equals to 0 by 2. That means the average just before and after the value. So at t equals to 0, the value will be the average of two values. Those values are the before value and the after value of t equals to 0. Okay. So how what will be the value? Then u0 minus. What is u0 minus? u0 minus is 0. u0 plus is 1. So what will be u0? u0 will be u0 minus plus u0 plus, that is 0 plus 1 by 2. That means average of this value and this value. So it will be half. Okay. So this is step function. Now what is the practical significance of a step function? Step function is actually used in control system for certain cases, like for time domain analysis we will see why step function is used. Let me give you a general idea, a practical example. Let's say you have an antenna to track a satellite or something like that. Okay, so that antenna, let's say this is the antenna, this is the satellite. The satellite will send some signal and antenna will receive. Now this satellite will move in any path, so this antenna must follow this path. Now let's say the scenario is like this. The antenna were stopped at a moment, antenna stopped at a moment. Now within that point it was pointing in this direction. Now because the satellite was in this direction, but the antenna suddenly stopped because of some reason. Now the satellite continues to move. Now the satellite is now at this position. Instead of this position, it is now at this position. Now there is a change in distance. So at this moment, when the satellite is in this position, the antenna starts working. So what will it get at as an input? It will have the position of the satellite as input, and based on that input it actually moves towards the position of the satellite. Now the position is changed from here to, let's say, point A to point B. Now the antenna will before the starting of the antenna, I am denoting the starting of the antenna as t equals to 0. Okay, before t equals to 0, antenna was directing towards A. Before t equals to 0, antenna was directing towards A. Now just after t equals to 0, antenna will get the signal to make its direction pointing towards B. So this kind of abrupt change is called a step change. This is a step change. Now look, if this is the value A and this is the value B, now before t equals to 0, the value was A. Now suddenly at t equals to 0 plus, the value gets changed to B, and the antenna must respond. Like if this is the input, before starting of the antenna, the input was A, still there. Now the satellite changes its position continuously, but when the antenna starts at t equals to 0, it gets the input as B value, not A, because the new position of the satellite is B. Now the antenna should move from A towards B, so it can have this kind of response. It will move towards B. So using step signal, now I have designed a control system for this antenna. Okay, this is the control system for this antenna. Now I will give this kind of step signal here, this kind of step signal here, and I will see what will be the output. It can be like this, it can be like this with some oscillations, or like this. So by using step signal, by using laboratory generated step signal, I can imitate this situation, this practical situation. That's why we use standard signal. If this kind of situation happens, how will my system behave? That can be actually predicted by using some laboratory generated signal. Okay, this signal can be approximated with this condition, or this condition can be approximated in laboratory with this signal, and we can actually see how my system will work at the when it is applied to this kind of situation. Okay, so this is step signal. What is step signal? Again, there are a lot more things, like let's say you have a AC, you have a AC and an air condition in your room. Now it is giving you, let's say, 25 degrees centigrade. Okay, now suddenly using your remote, you change the temperature from 25 degrees centigrade to 16 degrees centigrade. Now the system which was controlling the temperature of the room was controlled as 25 degrees centigrade, isn't it? Now it was controlled at 25 degrees centigrade. Okay, now whenever you just pressing the button of the remote, you commanded the air condition to control the temperature, instead of at 25 degrees centigrade is at 16 degrees centigrade. Now that time, the instant, will be called as t equals to 0. At that instant you are actually changing the input from 25 to 16 degrees centigrade. Okay, so before t equals to 0, the temperature command was 25 degrees centigrade, the set point was 25 degrees centigrade. Now at and after t equals to 0, the command becomes 16 degrees centigrade. So this condition again is a step, but having a negative direction. It's a negative step, but this condition can also be considered as a step. This kind of situation can be approximated by a step signal. If I generate a step signal having some negative step, and then I give that to the control system I designed for the air condition, then I can denote what kind of response that will have. Like this is the input, this curve is for the input. Now if this curve is for the output, let's say my temperature was controlled at 25 degrees centigrade. Now the AC must accomplish the task to control it at not at 25 degrees centigrade but at 16 degrees centigrade. So it cannot instantly control it. What it can do, it can follow this kind of path. Slowly it will reach 16 degrees centigrade and it will remain at 16 degrees centigrade, or slowly it will reach 16 degrees centigrade and due to some inertia property it will go lower. Again it will try to again come back at 16 degrees, so it will again reach 16 degree, and again due to inertia it will go beyond 16 degree again. So like this oscillation will be happening, and at a certain time it will be controlled at 16 degrees centigrade. So what will be the response, whether this oscillatory behavior will be the response, or this straight behavior will be the response, or this can be slower, or this can be faster, those things will be analyzed using step signal in laboratory before manufacturing the air condition. Okay, so that's why we need these kind of signals. So this is step signal. Now one more thing, what is step signal? Step signal is defined as the value, the amplitude is, this is the amplitude, not the area, this is amplitude. Okay, this is amplitude. For t greater than 0 the amplitude is 1, for t less than 0 the amplitude is 0. Using Gibbs phenomena I can give what is the value of t equals to 0, that is at t equals to 0 the value is half, because the average of these two will be this. So 1 plus 0 by 2, that is 1 by 2 will be the value at t equals to 0. And if I have a coefficient before ut, then this coefficient will affect the amplitude. This coefficient will denote the amplitude of the system. Okay, so then this will be a by 2 and this will be a. Okay, so AUT is general step signal, where A is the amplitude for t greater than 0 and 0 is the amplitude for t less than 0, and at t equals to 0 there is discontinuity happening. That's why using Gibbs we can predict the value by making an average, like a plus 0 by 2, a by 2. So this is step signal. Now we have learned impulse signal and we have learned step signal. So what is impulse signal? Impulse signal can be denoted by delta t and a delta t, where a denotes the area under the curve. AUT is the step signal, where A is the amplitude. Okay. Now Laplace transform of delta t was 1. What about Laplace transform of ut? Laplace transform of ut is 1 by s. I don't want to derive it here. because this concept is from signals and systems, but it will be needing in control system. The Laplace transform of step signal is 1 by s. Now if instead of delta t it is a delta t, if instead of delta t it is a delta t, then the value would be a. If instead of ut it is a ut, then the value would be a by s. Because Laplace transform is a linear operation. This linear due to this linear operation, the scaling factor will be taken outside. Okay, so the Laplace transform of step signal is 1 by s. The Laplace transform of step signal is 1 by s. Just remember this value. Okay, now the next one is ramp signal. So we have learned impulse signal, step signal. Now the next one is ramp signal. What is ramp signal? The ramp signal can be represented by this symbol RT. Okay, so what is the value of RT? RT is equals to t for t greater than equals to 0 or 0 for t less than 0. RT is t for t greater than 0 and 0 for t less than 0. That means the thing will be t equals to 0, 1, 2, 3, 4, 5, let us say, and in this side 1, 2, 3, 4, 5. Okay, so how the signal will look like? Before t equals to 0, the value was 0, so no problem. At t equals to 0 and greater than t equals to 0, it is t. So at t equals to 0, it is t. The value of t is at t equals to 0 is 0. So this is the point. At t equals to 1, the value will be 1. At t equals to 2, the value will be 2. At t equals to 3, the value will be 3, and it will be a straight line passing through origin. This is a ramp signal. Okay, this is a ramp signal, and this having a slope of 1, having a slope of 1. That means, yeah, obviously it makes sense. The amplitude is 3, the time difference is 3, so 3 by 3 it is 1. At this point the amplitude is 2, the time is 2, so 2 by 2, 1. So the slope is 1. Now if I instead of in this manner, instead of RT, if I write it as ART, then it will be AT. It will be AT. And what is the slope of AT? A will be the slope. Okay, A will be the slope. You can draw this, because let us say randomly 2 points I am taking. Let us say t equals to 2. At t equals to 2, AT will be 2A. At t equals to 3, AT will be 3A. So what will be the that means it is T1, it is T2. What will be the value of the slope? The slope can be given as AT2 minus AT1 by T2 minus T1. So what will be the value? AT2 is 3A, AT1 is 2A, T2 is 3, and T1 is 2. So it will be A by 1, that means A itself. So this A is represented, this A, coefficient A, will represent the slope of the curve. Okay, slope of the curve. This is ramp signal. This is used in control system, but not much, because there is a concept called Bibo stability, bounded input, bounded output. I will say what is bounded input and what is bounded output whenever I will discuss Bibo stability, but remember, ramp signal is not a bounded input or a bounded signal. That is why ramp signal is not much used. But for sometimes it may happen that for approximating some practical scenario, I need to show ramp signal as its ramp signal as a behavior of the practical scenario. To approximate the practical scenario, I can use ramp signal. That then we will use ramp signal, but not much in control system. Okay. So this is ramp signal. Again, what will be the Laplace transform of ramp signal? RT will be 1 by s square. Okay. Or if it is instead of RT, it is ART, then it will be A by s square. So this is ramp signal. So what is the signals then? What are the different kind of signals? There are a lot more signals that will be discussed later, but as of now I will close this lecture now. Just let me summarize. Impulse denoted by delta t. At t equals to 0, the amplitude is infinity. At t equals to t not equals to 0, the amplitude is 0. For 0 minus to 0 plus, the integration of delta t over t will be 1. The area under the curve will be 1. And now instead of delta t, it is a delta t. If it is a delta t, then at t equals to 0, the amplitude will be still remaining at infinity, and at t not equals to 0, the amplitude will be still at 0. But the area under the curve, that means the integration 0 minus to 0 plus delta t over t will be a itself. Okay. And the Laplace transform of delta t will be given as 1, or Laplace transform of a delta t will be given as a. Now the next one is step. What is step? Step can be written as ut. The amplitude of ut for t greater than 0 is 1. The amplitude of ut for t less than 0 is 0. At t equals to 0, it is having discontinuity, but using Gibbs condition, I can predict the value of the value of this curve ut at t equals to 0. It will be the average of the value after and before the t equals to 0. That means the point of discontinuity. Okay. So ut, and if instead of ut it is aut, then the value, nothing will change, only the amplitude will be scaled by a factor a at t greater than 0. Okay. For t greater than 0, it will be a instead of 1. Now Laplace transform of ut is 1 by s, and Laplace transform of aut is a by s. Okay. So the next one is ramp. It is denoted by RT. It is denoted by RT. The value of RT for t less than 0 is 0. For t greater than 0, greater than or equals to 0 is 0. Okay. RT I have written it as t for t greater than equals to 0, 0 for t less than 0. Now this equality sign, instead of being here, it can be here also, because for t equals to 0, the value of RT, that means for t equals to 0, the value of RT will be 0, because if the equality sign is here, for t equals to 0, the value will be 0. If instead of here the equality sign is here, then also the same thing will happen, because RT equals to t for t greater than equals to 0. So it will be the value of t itself, and t itself is 0, so it will be 0 itself. So one can be used, equality can be anywhere, either here or here. Okay. So RT is t for t greater than equals to 0 and 0 for t less than 0. Now what is the value of RT, what is the value of ART? This A will represent not the area, not the amplitude. Here the A represent area, here A represents the amplitude, and here A will represent the slope of the curve. Okay. Now what is Laplace transform of RT? Laplace transform of RT will be given as 1 by a square, and Laplace transform of ART will be given as a by a square. Okay, so this is it. Now whenever the value of a is 1, this signal will be called as unit signal. That means for a equals to 1, impulse will be called as unit impulse. For a equals to 1, step will be called as unit step. For a here is equals to 1, ramp will be called as unit ramp signal. Now whenever impulse signal will be given to a system, the system response will be called as impulse response. For step, it will be called as step response. For ramp, it will be called as ramp response. We will deal with impulse response and step response in a detailed way. Among these two, step response will be discussed mainly, but in some cases impulse signal is needed, because impulse signal will give us information, important information about the system itself, not the input output relationship. But the step response is needed everywhere, and we will see that. Now the next signal will be, there are parabolic signal, exponential signal, and sinusoidal signal. I will discuss about parabolic signal and exponential signal a bit in the next lecture, and we will discuss in detail the sinusoidal signal. And the sinusoidal signal, if whenever sinusoidal signal is given to the input of the system, then the system response will be called as frequency response, because sinusoidal signal mainly varies with respect to frequency. We will see that. Okay, so this is this much for today's lecture. Hope you have enjoyed the lecture. This is the basic 3 elementary signals. Okay, this is called singularity signals also. Now I am closing this lecture today. Thank you.